Hello and welcome back to another episode of From the Field. I'm your host, Casey Orr. If you have been online for a little while, then about 5 hours ago, we did a special stream with Roger, Nick, and Chris that went over how to modernize your technology stack and also take into account the whole cultural and people side of things. It was an awesome show. So if you do have some time after this, I would highly recommend that you go back into the VODs and give that one a watch. Now, this is the second in a series that Vera will give us a little bit more information in the future. And I just want to also mention to everyone that Thursday next week at 3 p.m., so 2 hours after this show in your own time zone, is when we're going to be doing What's New in Connect, which is where we do bring in the APJ head of Connect marketing, and he will go through new features, and also one of the amazing senior architects in Australia. If you want to view the VODs, then if you go into Twitch and just click the video button, and that will highlight everything there for you. All right, Vero, do you want to give yourself a quick introduction and then tell us what we can expect from this stream, and also talk about the series that we're running?
Awesome. Thanks, Casey. Hi, everyone. Nice to have you joining us today. Like Casey said, this is the second part in a series of sessions that we'll be running. We're running a series on GenAI Masterclass on AWS. Today's session is all going to be about RAG, but before we get into any of that, my name's Viral. I'm a senior solutions architect, been with AWS just under 3 years, 2 decades of industry experience across IT, predominantly working with media, entertainment, sports, gaming, and telco customers. In the last year, I've been doing a lot of work on GenAI, and it's fascinating to see how far it's come in a very short period of time. Much faster than any other technology I've seen, actually, and I'm super excited about what the potential holds. I said this is the second part. Quick recap on the first one that we had. 2 weeks ago, we had Ratan and Natalia on the stream, and they did a 101 on Bedrock on AWS. So they walked through ClickOps in the console, showing you what Bedrock is, our service within the GenAI space. Ratan popped up the console, ran through a bit of code. And so what we're going to do is we're going to kind of start from that position on and kind of walk through the next steps once you're armed and dangerous with knowledge of Bedrock. Before we get into it, Casey, back to you.
Awesome. Yeah, before we jump into it, Fraser, why don't you give us an introduction on your side? And I hear that you're streaming all the way from Mumbai. You are muted.
Hey, hi, Casey. Thanks for having me here. I'm Fraser Sequeira, a solutions architect at AWS based out of Mumbai. And I work with startups in India, so fintech, ad tech, health tech. All of these startups, they have multiple GenAI use cases. And that's where retrieval augmented generation plays a crucial role. That's the topic for today. I'm truly excited to be here and share my knowledge and insights on retrieval augmented generation. So with that, I think let's get started. I'm sure everyone here who have tuned in are aware of what large language models are. They are foundation models that serve multiple use cases, unlike your traditional models, where you needed a model for every use case, like translation, sentiment analysis, OCR. All of this can be done with a single large language model, like a Llama or a Claude or a GPT. So most of the use cases can be solved here. However, each of these large language models, they have a knowledge cutoff date. A simple example for all who have tuned in, you all can just quickly go to your favorite large language model and try out this query. What are the number of moons on Saturn? And you'll realize that each large language model gives you a different answer because they have a knowledge cutoff date. If you go to the official NASA website, it says there are more than 140 moons. So that's the challenge. That's where RAG comes in. If you're trying to build your own chatbot or a virtual assistant on your private data that a large language model has never seen, it's new knowledge to the large language model, that's where a non-parametric method like your retrieval augmented generation would come in. So with that, I think what we can do right now is we can look at what retrieval augmented generation is. So Casey, could you just share the screen?
There you go.
Yes. So retrieval augmented generation, it's a 3-step process. You retrieve the data from your external knowledge base or your vector databases. The user query or the user question is then augmented with this additional context from the vector database. And then this entire context is passed on to the large language model. The benefit of this system is reduced hallucinations, more accurate results, and the best part about retrieval augmented generation is provenance. So we can always go back to the source. So if you're coming from a legal domain or a tax domain, we have multiple customers in India who are working in these domains. They are building finance bots, tax bots, legal bots who help draft legal documents. It's important to have access to the origin, to have access to the source. And that's where RAG is a more economical way to feed this new knowledge to a large language model. So we can then also look at, we can go a bit more into the depth of RAG. This is how a RAG would look like. You all can, if you all are not aware, if you all are aware of vector databases, just type in the chat which vector databases you all are currently using. But this is the overall flow of how a RAG system would look like. You have the data ingestion workflow and the text generation workflow. You have all of your data stored in a database. You embed this data, that is, you convert it into a numerical representation. So it's a text to numbers, document to numbers. And you do it via an embedding model that encodes your documents into dense vectors or a numerical representation and stores it in a vector store. What this allows those vector databases to do is it can then fire a KNN or an approximate nearest neighbors query and find out relevant documents that are similar to each other. So when the user is querying the large language model, say I ask some information, what's how much tax should I be paying, or anything, what are the tax deductions available, or if I'm asking the finance bot, how is the Apple stock doing, it first gets into the vector store, gets all of the relevant information, and then it augments the data, it augments the query with this additional context and passes it on to the large language model. So your query from the user is also embedded. It's also converted into dense vectors, and you're matching the query with the documents through a similarity search. So if you have any questions on this, just pop it up on the chat. Back to you, Viral.
Yeah, so some of the things I've been observing, really great that you've shared that, Fraser. Some of the things I've been observing in this space is how unique the RAG proposition becomes when you're trying to do things in an enterprise space or in a business space. Over the last year, everyone's become so familiar with the consumerization of ChatGPT and all the models you get on your phone and the little apps that you do to make life easier for yourselves. But when you try and shift that into a workspace, when you're trying to do workflows, when you're trying to do actual business-related things, it becomes interesting. There's the obvious ones of you can use your LLM or the GPTs to become like a very intelligent search. You can have a conversation with, you can curate content. But when you want it to be on content that's specific to you in your business context, in your organization, or if you've got workflows, if you've got special things of knowledge of ways to do things within your organization. And so that's where RAG comes in really handy. Some of the things that are really, really interesting for me is just to see how we can augment an LLM with your normal conversation with RAG. The one thing that's been more challenging is to bring both of those together. More often than not, when you're going down the RAG path, you'll make a query down into your vector store, and only knowledge that's brought forward from that vector store is then available. And so you use the benefits of the LLM to understand language, to understand summarization, to understand synthesis on those vectors that come back. And getting a fine balance between how much you use the responses versus how much you make up yourself based on the knowledge you have is also an interesting one. maybe Fraser, you could talk to us about some of the challenges and techniques around RAG and how we kind of bring all of that together.
There is
Sure.
also there's also one question in the chat which is kind of interesting, talking about if you do use RAG on top of a large language model, like in the context of well, their one's ChatGPT, but in our context of Bedrock, does that ever get used to feedback into that large language models like training?
I'll take that
Like,
question maybe.
what's
It's a really, really good question. In Bedrock, the way things come together in the AWS offerings, it doesn't. The simple answer is it doesn't. But how pragmatically it comes together, the way we've put Bedrock together, we have native LLMs that are our own AWS ones within the Titan family. But we have a large collection of third-party models that we also make available. So there's the Llamas, the Anthropics, the Mistrals. There's a whole long tail, and it's an ever-growing family in there. The way Bedrock presents itself as an API abstraction on top of these models means that the security that you're familiar with AWS and how you deal with any of our services also applies to Bedrock. And so those third-party knowledge providers make the model available to us in a managed Bedrock account, and you consume that service for inference. So you pass in your prompt, you get your response, but the data that gets passed in as part of the prompt never makes it to the model providers, and therefore cannot be used for training, further training. And so it's just in time. You put in your context as a prompt, ask something, you get an output, and it's transient in that state as well. Fraser, anything else you'd like to add there?
Yes, you have summarized it well. So yes, that's exactly your RAG data is not really used to train the model.
One interesting point there as well is the nuance between training, fine-tuning, and prompt engineering. Where RAG sits in that is, like I said, the technology has changed so much in such a short period of time. A year ago, when it was really early days for a lot of these maybe more capable offerings where we've stacked functionality together, the only pathway to success was you take an LLM, you fine-tune that model with your content in it, and essentially you're embedding your content, you're exposing your content to that model and making it part of the fine-tuned model. Prompt engineering is you're passing stuff through in context, and RAG kind of sits nicely in the middle between there. But Fraser, maybe you can talk a little bit more about that.
Yeah, so I see the questions now. So also to add this feedback loop concept that you have, right? What you could do is store all of these conversations that you've had with the LLM in a database. So the next time you enter and you start typing in, your LLM, your bot is context aware. It has the RAG data as well as the entire conversation store. That could be used as a feedback mechanism. The other thing that you could do at scale is prompt engineering. So that's the way you have large language models that support 200,000 tokens. So they can actually read an entire book for you. If you have rules, if you have any feedback examples, you can actually add it to the prompt, to the system prompt. And if you want yours going one step ahead, you could also add these conversations before you start in a new conversation. So it keeps track of all your conversations. And once the conversation has ended, you can actually summarize that entire conversation and store a minified version of it rather than storing the entire conversation. And then add it to your system prompt. The next time you type in, the LLM has more context of what has transpired, and it will able to serve you better. Okay. So do we go to the next? Yes. So what we can do is we can actually share some links to help you get started. So at the end of the session, we can share some links on how you could build your own RAG solution.
Sounds good. Viral, before I interrupted you and went down this slight tangent, what was your question to Fraser, just so everyone can get a refresher?
Oh, yes. So, Fraser, I was asking if you wanted to share some like different RAG architectures, tips, techniques, what makes RAG challenging? Yeah.
Sure. So yeah, Casey, could you just share my screen? So we have seen the entire RAG architecture where we have a vector database that's quite capable. It can compute the distance between vectors through various distance metrics. You have cosine similarity, Euclidean distance. All of these are you can do it. Now, going one step ahead, what are some of the ways in which you can optimize these RAG solutions? So let's look at some of these ways, and then when we come to the demo part, we'll also look at how this data is stored in a vector database. The first way is retrieval enriched with metadata. And in this way, you are splitting your document into chunks. You can use any of the splitters that are available in the LangChain library. Split the document into these chunks, and you add some metadata to these chunks as well. So when we get to the demo, we'll explain all of this in detail. Now, what this does is if I am querying, if I'm just asking questions for what is the annual revenue of Amazon, right? And I have years and years of revenue data for Amazon, it is just going to give me uh, an incorrect result, an incorrect answer. But what is the revenue for Amazon in the year 2023? And if I add this metadata that this chunk belongs to the year 2023, right? I tag my chunks, then that is going to narrow down the scope of my search in the vector database. It will improve my query latency. So this is one of the ways where when you're chunking the data, you also add some metadata to the chunk. You add the source information, like we were talking about provenance, where you can trace back the origin. You add the source information from which S3, from which file you have picked up this data. You can also add which year this data belongs to. And then when the user is querying for this data, you identify the keywords from that query and you apply a vector search or you apply a lexical search on that data. So this is one way to optimize your RAG architecture. The other way would be a hybrid search. It is supported in OpenSearch, in the open source version of OpenSearch, as well as the open source OpenSearch provisioned cluster mode. The hybrid search is, let's take an example, right? What is the cost of a Harry Potter book? So here, Harry Potter could be the keyword where I do a keyword search, and cost could be also referred to as price or charge in my underlying document. So I'd want to do a semantic search as well as a keyword search. So that's again another way in which you can improve your current RAG architectures by doing a keyword search as well as a vector search or a semantic search. We had some customers in India who wanted to only give access to certain documents in their knowledge base in the vector store. So these two approaches, where you're tagging, where you're adding metadata information, where you're doing a keyword search, really helps to narrow down the scope and give you better results from your vector database. The next one is this is my favorite network of agents, and I'm sure we are moving in this direction. So you'll see a lot of agent-based frameworks popping up this year. And here you have a master orchestrator. There is an agent. The agent will decide if it has to call a vector database or if it has to call a Python function or if it has to get more details from the user. And you can have multiple agents who are working together to solve a problem. So this is this I think, yeah, we are moving in this direction, and this is the way we'll see most RAG architectures evolve, where you have agents that have a certain number of tools or functions, and they can call a RAG, or they can call the internet, or they can do various other API calls. They will collaborate and try to solve the problem for the user. So if time permits, we'll try and see if we can give you a demo on this. The next one is query rewriting. So sometimes what could happen is, again, a client or the end user may not write the correct query, which may result in incorrect results. What you could do is you could have an LLM rewrite the query for you to give you better results from your vector store. Uh, so this coupled with ranking or re-ranking of your documents or sorting your documents by timestamp, giving higher scores to the latest documents. So all of these approaches, in a way, can help you optimize your RAG architecture. Yes. Over to you, Viral. I hope that was
Sure.
helpful.
Yeah, that was really helpful. I'm conscious it's been 20 minutes. Really keen to get hands on keyboard and start jumping into some code. But before we get into that, I see a question, Daily Push, around typical using small LLMs, and can you introduce RAG within that? And the answer is absolutely you can. And I'm going to show you a couple of examples in code now, but the next demo after my one, when we get into OpenSearch, we'll kind of showcase some of the nuance of how you could do that. Remember the way vector stores come together. There's also vector stores as a service. So you could actually do your break RAG into two parts, have a small model that's capable in what it does, but the ability to call into a vector store to query individual knowledge elements, and then pass those knowledge elements as context into your LLM to be able to do stuff with it. So I'll quickly jump over into a small demo and run through some code.
I will show you screen. There you go, your screen's all good.
Cool. So I was thinking about what's a nice way to kind of put this together without getting overly complex, just to show the main bits and pieces. So just kind of building off as we level up off the last episode we ran in the series. The last one walked you through how you go into AWS console, how you enable a model for consumption, how you use the different APIs within Bedrock to be able to do things like an inference, as well. So we're leveling up a little bit more from there as we walk through this. So I've created a SageMaker notebook here. I'm within SageMaker Studio. If you're not familiar with the environment, super helpful to be able to do things really quickly. And in here, I've got a couple of code cells that I'm going to walk us through as we build this thing together. But in principle, we're going to kind of quickly recap a lot of the stuff we've spoken about. What I'm going to do is I'm going to go in and use Boto 3 within Python to be able to create a connection to Bedrock. We're going to do things like an inference, just to recap what we had done really quickly. But then we're going to move into creating a knowledge base. And then doing this RAG out of Bedrock knowledge base. The way Bedrock knowledge base comes together, till very recently, we only had one way within which you could put knowledge into that knowledge base. It was an S3 bucket. You drop your artifacts into that S3 bucket, text files, whatever they may be, and knowledge base indexes the context and the contents within that bucket, and then you can run retrieve and generate type commands off of that. Very recently, we've launched a new feature that allows you to use external sources. And the very first source that's in there is to do in-memory RAG. And so what that means is the ability to do things like have a conversation with the document. You don't have to create the S3 bucket. You don't have to put your document in there. You can embed the document as part of your call. And so that's kind of the steps we're going to walk through here. Murphy's Law being Murphy's Law, I prepped this code a couple of days ago, and in usual fashion, the libraries have updated and some of my stuff didn't work. So I'm just going to quickly get my keyboard working again, run through just making sure I got the latest libraries for Boto Core, the frameworks in there. And so that should just run through super quickly. And I'll restart my kernel just to make sure I'm ready to go. Hopefully I should have everything in there.
I believe in you.
I believe in myself. This is going to be very funny if it doesn't work. No, I have full faith it's going to work. Cool. I think that's all done. 2 more to go, 1 more to go. Right, let's restart the kernel, and we're away. Restart the kernel. OK, so in this first code block, what I'm doing while it restarts is I'm importing Boto 3. I've created a function. And within this function, what is it doing? It's taking a variable in, which is the prompt. The reason why I'm doing this as a function is as I go through the code base, I can just keep reusing the function instead of having to do the code every time. So I'm taking an input with a prompt. The first thing we need to do to be able to kind of engage with the Bedrock API is we need to create a client and initialize it. So Boto3.client, within the variables I'm passing through in the config here, calling the service name. For this example, I'm going to be using Bedrock runtime because we're going to do an inference. And the region I'm using is AP Southeast 2, which is Sydney. For those of you who weren't joining us in the last session, Ratan kind of shared we've launched Bedrock as a service within Sydney region, so that's really cool, something closer to home for us in ANZ. The model I want to use for this demo as we walk through is Anthropic Claude Sonnet. So again, Ratan showed us how you go to console, go into Bedrock, and how you find the model IDs there. So this is the model ID for Sonnet. And then I've just created a try-catch block in there. And effectively what I'm doing is I'm making a call to Bedrock client that I've invoked with the invoke model method, passing through the model ID. And in the body, I'm creating the config. In this, I'm instructing it maximum tokens of 1024. When Claude 3 came out, it introduced a new format in which you interact with the model. And so within the new messages format, you define a role, in this case, user, and then you pass the content in. So I'm passing content of text, and then that variable I created, prompt, is going to fill into that. Claude 3 is multimodal, and that's why it's got this messaging and the content. So you can pass an image in, you can pass text in as well. And then at the end, I'm just doing a couple of hygiene things, grabbing the response, going into the response. There's a bunch of stuff in the payload. We're not going to go through everything today. But the two things that I'm really interested in is I'm going to print the number of tokens we used on the input and output. And the other thing I'm going to do is I'm going to print the response. Usual error handling hygiene at the end there as well. So I'm just going to quickly run that cell. So we've got the function ready to go. And so this is where we kind of left off in the first session. In this particular one, I'm going to ask Claude through this call. I've got a prompt in there. I haven't actually done any fancy prompt engineering here, but essentially all I'm asking for is I want to generate 5 names of fictional characters with a short description about each one of them for characters that should have been in The Hobbit but weren't. So I'm going to quickly run that through. Effectively, what I'm doing is we're creating this output underneath. So in my prompt instructions, I've been a bit clever in putting in some detail around how I want the output formatted. So I've got the list should be comma separated in quoted string. So I've got a new line for every character, entirely fictional made up, and a description around it. And so to show how RAG works, I'm just going to pick one of these. And up till now, we really haven't done anything in the RAG space. We're just setting ourselves up for success. So here what I'm doing is I'm taking that fictional character we've just created, and I'm passing it to Claude via Bedrock. And I've asked it the question, how old is Aldrin Oakheart? Nothing like impromptu names in a live Twitch session. And what Claude has come back with in here is some preamble around, this is a made-up character. I have no idea who the character is. And just reading through this really quickly, it's talking about there's no widely known fictional characters about this. And because I don't know who it is, I need more context to answer this question. So that's kind of summarizing the problem space that Fraser started off with around the LLMs are trained to a certain data point in time. Their knowledge is exposed to a certain amount of knowledge. And in this case, I'm showing Claude Sonnet has no knowledge of these characters. So what I'm going to do next is now we're going to transition into a RAG augmentation around this. And so I've got another prompt here. And in this prompt, what I'm doing is I'm taking that 5-character output, and I've created a prompt here that says defined for Claude in terms of how you instruct Claude to do things. What's worked really well for me is you start off your prompt with instructing Claude around a persona or a role. So in this case, I'm saying you're an expert in all things Hobbit. Then I've given it an instruction. You've been asked to create character biographies for, and I'm passing article titles, which is the variable I called the output of those 5 characters we just created. So I'm passing all those 5 characters in and into that prompt, and I'm saying, create a bio for each one of these characters, include their birth date, don't include any preamble. So I'm just going to let that run through as well while I go through the rest of the code. And hopefully, in a second or two, we should see those bios. What I haven't done in here is when you're running these calls in the code, there's kind of two options. You can have a streaming output or just wait for the entire output and print it. I haven't gone with the streaming code just to keep it simple. So if you were in the UI in console, you'll see the LLM responding and typing out words. In our case, we just have an awkward pause of it's doing it behind the scenes, and I just dump it at the end. And so in here, what I've got is my input prompt was 241 tokens. The output is 680, so that's that formatting I had done in our function above. And here's a bunch of those bios. So the 5 characters we created up above, Aldrin Oakart, bunch of others. In my prompt, I asked for birth dates. I have no idea how this works within the canon of The Hobbit and timelines, but Claude has figured that out for me. And it's created a nice bio for each one of these characters within that story arc. So armed with this, this is the knowledge artifact I want to use within my RAG example. So before we get to that, what's the first thing I want to do? The first thing I want to do is create the knowledge base, Bedrock knowledge base, and embed this artifact within it. For this example, I'm not going to go down the pathway of creating a file, putting it in S3, and putting it into knowledge base. I'm going to use the newer function or feature that we've just had, an in-memory knowledge base and RAG implementation. So for this, I've got another function. I've called this function invoke KB, which is the knowledge base. The input is what I'm passing through the question into this knowledge base. Similarly as above, we've got similar sort of configs. The one thing that's slightly different when you're setting up a knowledge base, the config expects the model ARN instead of the model ID, because we're just funny like that. And so I've got some code in there to take the model ID, convert it into model ARN. When we initialize the client, this time we're using a different one. So when we're doing the initial invoke, I'll just scroll back up so you can have a quick look. We used the Bedrock runtime. But for this client that I'm establishing in this new function, we're using the Bedrock agent runtime. Again, I've got a try-catch block, general hygiene down the bottom around error management. But within this client, Bedrock agent client that I've created, we've got a function or an API endpoint called retrieve and generate. So within knowledge base, we have 2 offerings, one being retrieve. So you'd go and pass a query into the knowledge base, and you're retrieving the nearest neighbors, as Fraser described them, from that vector store. And you can, within the config, say, how many do I bring back, and the rest of that stuff. And so to your question that was posted before, you would use that to say, retrieve all these chunks of contextual information, and then pass that to an LLM and do something with it. Retrieve and generate, what I'm using now, is effectively doing that for us in a managed way. So it's going into the vector store, grabbing those nearest neighbors, relevant information, passing it to the LLM. LLM's observing everything that's relevant and synthesizing an answer on top of that. Input is that variable. And the last bit I'll kind of show before we jump into the actual example is how we set up the configuration for that knowledge base. So in this particular case, for the retrieve and generate configuration, I've got of type external sources. So the 2 we support now is knowledge base, which is that S3 bucket way, or external sources. And in here, I'm passing through the identifier of the biographies. And the data here, if you had a file, you'd use a text reader. You'd go and read the text file, dump the binary data in here, in my case, or the string, depending on what it is. In this case, I've just kind of used the variable of the article we just created, which was the bio, and I'm just passing it straight in here. So I will go and run that, just so we have the function ready to consume. Last 3 bits of the code demo I want to show you. What I'm going to do is I'm going to go and call that RAG that we've just set up. And I'm going to ask it a question of who is Aldrin Oakart. So earlier on, I went to Claude Vanilla and asked this question. And it came back with, hey, I need more context. It's a fictional character I don't know about. Let's see what it says now. And so what it's done here, in that function that I created above, I'm logging out only some elements of the JSON response, not everything. But what I've logged out here, this first block is the LLM synthesized response. So in here, what it's done is it's gone through. Citations down the bottom is showing us it's gone into that vector store, which is that single text article that I exposed to it. It's come back with citations. So it says, based on your search query you've put in, here's one block of data in that citation that's pertinent to your question. And then it's gone and done a LLM inference on top of that citation. And this block on the top is a summary. So my question was, who is Aldrin Okart? And it's gone and taken those, 20 lines of text and summarized it quite nicely into 2 sentences. So in this case, he's a gruff but loyal dwarf warrior born in the foothills of the Blue Mountains, and summarized that quite nicely in there. I could change that to say things like, how old is, or let me go with, when was Aldrin Okart born? Let's try that one. And so in this particular context, the LLM has notion of age, dates, and it's gone into the RAG, and it's looked at the text that was there around him, and it's gone in and pulled out, he was born on this year in the 3rd age, and all the rest of that stuff. And wrapped it quite nicely in terms of readable English. So this kind of brings me towards the end of what I wanted to showcase as a teaser to what you can do with RAG. The one bit I will show you to kind of bring us home and close us off, in those 5 characters, fictional characters that we created, there was no golem from The Hobbit and the Lord of the Rings. So I'm going to go in and I'm going to call that function that I have of invoke KB, and I'm asking the question of who is golem. And given that data set we had, there was no golem in there. And we can see the example here of citation details. There were no references in that vector store for anything that was pertinent. And this is really nuanced and interesting because it allows you as the developer, as the builder, to kind of think around how the apps you create and the business logic you put in place makes use of this information. So if you're making an API call, in this case, you still have the ability to do things like, how do I present this output? If there's no citations in this, there's maybe nothing relevant. So maybe in my logic chain, the second example I've got here, I want to follow through with a second call to a generic LLM that's not sitting in a RAG context. So this is the second example that I've got here. I'm going back to that first function that I created. Let's just go to Claude directly, ask it who's Golem. It's done a valiant job of a lot more information than I would ever know about Golem and put it out there for us. And so in this particular instance, the way knowledge base in Bedrock has come together is it's limited the output within which it's summarizing. So in here it said, I could not find any information on the character named Golem in the search results out of that RAG vector store type thing. However, it's made some suggestions. The things I can answer are, we've got knowledge of these characters. And those are the 5 characters that we created, no knowledge of Golem. So for all of this, I haven't done any specific prompt engineering. I haven't instructed it to do anything finer. That's how it all comes together. I'm conscious I've kind of jittered through that, done a lot of talking. Any questions? Casey?
There's been a few, but we've been answering those as you've been talking. So
Awesome.
if anyone has any questions, do feel free to chuck them out there. Daily Push has been doing an amazing job of asking all of the questions, which has been great. I love it.
It's great.
Is there any considerations that people should, take into account when they're looking at building out a RAG solution?
Fraser, any thoughts? Are you just muted?
You're muted.
Yes, so wonderful demo, Viral. It was really good to see how Bedrock works and the capabilities of Bedrock with knowledge bases as well. RAG is also available in Bedrock for certain vector databases. Now, certain considerations when you want to look at that you building your own RAG solution would be the cost of a vector database is the scale which you anticipate. How many vectors are you going to store in your database? So as you scale, as you move to production, like we saw with some of our customers in India, they're building health coaches, right? For example, one of our customers building a health coach which tracks your sleep patterns and tracks your glucose levels, tracks various other details, and then provides you with a diet plan, nutrition tip, fitness regime, and nudges you towards your goal of a fit and healthy lifestyle. So they are dealing with massive volumes of data. When you deal with that kind of scale, when you want to store a million vectors, you should look at the capabilities of your vector database. Can it support lexical search as well as semantic search? Can it support hybrid searches? Can it horizontally scale? How cost effective it is? So these are some parameters to consider. Also, the trade-off between query latency and recall. Now, I saw a question on FIRES. So, yeah, you should also look at what all capabilities or what all algorithms are supported by your vector database to compute the distance. FIS is one, NMSLib is another. Within that, you have cosine similarity, you have inner product, L2, Euclidean distance. So all of these are some things to consider when building your own RAG application or choosing a vector database. Most importantly, see you if you should look at the performance of your RAG system. Just check the query latency, and if you're in doubt, reach out to AWS.
Yeah, Fraser, that if I was just to add like one more thing to that, maybe from a little bit more of a business perspective, on that as well, like within the family of product offerings we have within AWS, one of the things I say you should definitely consider is more aligned to the use case of where you're going to be using RAG as well. So within our family of offerings, we have today I've shown knowledge base. And if I was to like summarize that in like less than 10 words, I would call it a form of generative search. You have the ability to have all this knowledge sitting somewhere in a vector store, and you can use a hybrid search on top of it and do some generative response on top of those. So that kind of sits in the middle. If I was to kind of put a landscape of three offerings which we have in this space, kind of knowledge base sits in the middle. On the extreme right hand, we have exceptionally managed, like on the full end of managed end of the spectrum with our Q family of products within Q for Business. And that's really, really good if you don't want to influence anything that's happening in there. There's a whole bunch of connectors to third-party systems, all your usual enterprise stack items there. Last time I checked, we were north of 50. I think it's like way more than that now. But essentially, it gives you a chat interface within which there's a whole bunch of connectors where you can go in. And so in the example I've shown now, we've brought the data to knowledge base. Within Q for Business, it's connecting out to systems where the data is resting in place and indexing it there. What indexing means, it'll go and read that content, vectorize it, and make it available for interaction within a search, within a chat interface. And that works really well, but it only gets you so far. And therefore, the other end of the spectrum is we have Bedrock Agents. And Bedrock Agents gives you similar functionality, but gives you the ability to orchestrate. And so Fraser mentioned earlier around one of those architectural patterns around agents. And so Bedrock Agents allows you to create a collection of functions, utilities, tools, call it what you want, and help them and have them orchestrate off each other. And you can control the workflows a bit better, and you can control the instruction of what is your purpose and how do you operate. That's a teaser. The reason why I bring that up is that's a teaser into some of the content coming in the next few sessions of the GenAI Masterclass. So definitely stay tuned into those sessions if they're of interest. Sorry, Casey, you had a comment as well.
Oh, no, I was actually just going to mention, so that is going to be happening in 2 weeks, which is the follow-up to this at the same time in 2 weeks. So if you are interested in this and you are enjoying it, then definitely tune in 2 weeks. In terms of like, so we have gone over a few use cases and real-world examples, and we have been talking about OpenSearch a lot. Fraser, do you want to just walk us through like an OpenSearch demo or something like that, just to give a little bit more context?
Yeah.
And one very quick one before you go into it. How do you ensure your LLM doesn't introduce bias?
You can do it through prompt engineering as well as RAG. So it's how well you're able to prompt your system and ensure that uh, stays in relevant to your use case. Prompt engineering would be one of the ways I would try to address the bias issue with LLMs.
And an easy way to kind of give an example of that, Fraser, would be like in your prompt, put in the words, if you're unsure, say I don't know. A very easy way. It may not work in every context depending on the LLM you're using. You may have to qualify that a bit more in you don't know or unsure. But simple techniques like that actually go a long way.
Yeah, and one more, a step ahead to that, right? You can also control certain other aspects of your model responses through guardrails on Bedrock. You have hate speech, violence, abusive behavior. All of these things uh, can actually be controlled through guardrails, or you can identify the model toxicity, the toxicity score, and you can ensure that your model responses are in tune, or they satisfy the use case and are not diverging. Okay, so
Cool.
yes, let's get back to the open search demo because we've been speaking a lot about it. So I'll share my screen. Casey, could you put that up?
There you go.
Right. So we have, if you are trying to productionize your RAG solution, your RAG use case, you would need certain number of APIs. You would need to index your data. Your data could be in different formats, could be a PDF, a Word doc, a CSV, a text file, or it could be just someone pasting something on the console. You would need a query also. You would want to query that data. You would want to extract the data from PDF. So there are various APIs that you would need here. Now, what we have done is we have built a serverless solution for RAG. It's end-to-end serverless, and it's available on AWS Samples. It's a serverless RAG demo. You can look at the architecture for this one here. So we are using API Gateway, we are using Lambdas, we're using Bedrock. Bedrock is serverless. You don't need to manage GPUs on your end. You're not paying by the hour. You're paying for the number of input and output tokens for the large language model that you're using. We're using OpenSearch serverless. OpenSearch comes in three flavors. One is the OpenSearch serverless that's integrated with Bedrock. The other one is OpenSearch provisioned cluster, Amazon OpenSearch, and the other one is the open source OpenSearch that you can also install on your local environment. So if you're looking to even test it out locally, you can do that. You can go with either the provisioned or the serverless mode. We wanted it to be entirely serverless. That's why we went ahead with OpenSearch serverless here. So this entire architecture is serverless in nature, and we're just providing you with a very rudimentary HTML file. So don't judge me for that. But yeah, so this is how it would look. So once you install this on your system, you can install it through Cloud Shell. And the reason you would want to go ahead with this is if you want to customize certain aspects of the indexing process. For example, you want to customize your choice of vector database, or you want to customize the chunking behavior, the overlap that you want for your chunks. You want to add in some additional metadata. You want to narrow down the scope, or you want to alter the search behavior. That's where when you're looking at customizations, that's where you would look at this solution. Now, like I said before, a foundation model can do a number of translations out of the box with basic prompt engineering. So it can translate the text into various languages. In fact, we had a customer uh, in the advertising space, and in India we have many languages, right? And Textract is one of our services that does OCR, that doesn't really support all languages. But Anthropic Claude 3 was able to analyze the image, extract the data that was in Gujarati, a language in India, and convert it into English, and also write an Instagram and a Facebook post on it. So this is all possible with basic prompt engineering. It's out of the box. You can do sentiment analysis, all of this out of the box. But like I said before, if you are trying to have conversations on a certain document, you have millions of vectors, you have health data stored, patients' test reports are available with you. That data is continuously evolving. And in the real world, you will have this kind of data that is continuously evolving. that's very specific to your domain, which the LLM hasn't seen before. So in that case, you would want to use a RAG or want to use OpenSearch. So you would want to then index the data. For example, this is how indexing would look like. You have your text. We have chunked the text. We have added a tag on that text, and we have also generated some embeddings, right? So here I have excluded the embedding, but what we can do is to show you how the embeddings look like. Oops. Okay, so this is how, yeah, so let's look at the embeddings. Yeah, so this is how your embeddings would look like. This is how we are indexing and storing the data. We store the embeddings. We are also storing the text and we are tagging it as well. We have also added a timestamp here. So this allows us to do retrieval enriched with metadata. So we've added some metadata that this particular text belongs to revenue. And I can actually search for, say, revenue within tags, right? You can do something like this, so that, so if you have a user who comes who's a persona is that of a from finance or a business analyst, and they should only have access to the revenue documents, that's when you would want to tag your data, tag your text with those documents. And you can also boost the score of the matches found by this particular keyword search rather than the vector search. So you can do that as well. So this is a query. So what are the top contributors for the Amazon revenue? We have taken that query, we have passed it to an embedding model that has given us a numerical representation of that query. So we are doing a vector search on that query as well as on AWS text, right? So text. So we are doing a keyword search here, and it will get me all the documents that have the top contributors of AWS as well as the AWS keyword in my text. So it's doing both of these searches in parallel. So this kind of mix and match is possible. This is going to narrow down the scope of your RAG. Now coming back to our use case, or coming back to the solution here, we'll cover agents a bit later, but let's look at this one, right? So what are the number of moons on Saturn? You with Bedrock, we are accessing Bedrock here. We have access to a wide range of models through a single API. So that makes it easier to interact with all of these models. Now I have selected the latest one here, Claude 3 Sonnet. And let's just try to ask it this question. So it says that, it has 82 moons, which is incorrect. So what you can now do is you can index this document here. I have a document on Saturn moons. It's uploading the document to S3. Then it initiates the indexing process. We are calling textract here to extract the data from this PDF. And then we are indexing it into OpenSearch serverless, the vector store that we have.
It's always exciting watching the spinning wheel.
While that spins, I saw there was a bunch of questions in the chat around vector stores. So we've got OpenSearch, we've got Postgres with the pgvector plugin. I know Mongo does a vector store, Pinecone you mentioned, Casey. So there's a lot of choice and options in that space.
Right. Yes. Yes, there's a lot of choice. The one to choose is you should look at the performance versus the cost, the trade-off. RDS Postgres would be cheaper, right? It would be relatively cheaper compared to a NoSQL database, but the latency for a relational database would be quite high when you look at a million vectors. The P99s would be quite high. So that's where, if you're looking for performance, look at a horizontally scalable vector database. Okay, so now we have indexed our data. Now let's fire the same query, and this time we're going to query the knowledge base. Let's do that. And yeah, it comes up with 146 moons, right? So this is the way you can do it. And if you want the data in another language like Hindi, Thai, Spanish, you can try that as well. So you can see that Shani Graha may there are 146 moons. So this is the Hindi language in India. But now let's, if you even want to interact with your document, you have this conversational behavior where you store these conversations. So right now, all of these conversations are passed through the WebSocket. They are in memory. But like you want a feedback loop, then you would want to take these conversations, summarize it, store it in a database. And the next time when you come to chat with your document, you get the document context. You also get this additional conversations that you have stored. So the model has this feedback loop in place. Now let's look at the weather agent. I was talking about agentic RAG, right? So this is not agentic RAG, but this is will slowly move in that way. But what this is going to give you an idea of how agents really behave. So this is the weather reporter. I can ask it any question, whether in Mumbai. Instead of Mumbai, let's try Auckland. All right. So the agent is going to prepare a plan of how it has to answer this question. Okay, and it tells it is around 16 degrees Celsius. You all can confirm this. Uh, let's do 1 second. Mumbai. Okay. Okay, so let's go with this, right? This is the other agent. What I want to highlight here is this pink box. That is where the LLM is thinking. All right, so that was not visible in the weather agent, but in the hotel agent here, we have created a hotel agent. We have a set of rules, prompt engineered rules, and we also have like functions in the backend. So the agent has functions. So when we ask it to book me a room, it's going to think. The agent is going to evaluate what is the first step needed to solve this problem. It's going to come up with an entire task plan, and then based on that, it's going to decide. It's going to book the room for you, and then we have a series of steps here to define how this conversation should flow. So yeah, this is the Amazon Bedrock with OpenSearch serverless vector DB demo. We keep adding to this code, and if y'all are interested, I'll share the
Yes,
QR
if you can share a couple of those.
here.
Yep, awesome. Dev, because we did have a question asking for some resources.
Yes.
And if you're interested in that stuff, definitely come into the future sessions. We'll be looking at agents, we'll be looking at guardrails. And Fraser's done a great teaser on that demo, but definitely have a look at the blog. It walks through a lot of that stuff in a lot of detail, and that GitHub URL has the code base for that demo, so you can go and try it yourself as well.
Yep, and also the one thing I'll also mention is that guardrails has now been added to the API call for Bedrock, as on Boto, I believe, as of last week or this week. I can't remember. It's quite recent, but that is something that everyone should be aware if they have been waiting on that feature too. With that, we are running up to time, so thank you, Fraser and Viral, for your time. The next session, I was just getting to that, so great prompting there, Meow, is going to be in 2 weeks' time at this exact time. So in 2 weeks, just tune in, and the other one it's in 2 weeks after that as well. Cool. Thank you for your time, everyone, and with that, I will say Matiwa and see you in 2 weeks.
Thank you. Bye.
Thanks, everyone.